Precision medicine is actually, I believe, a revolution in the way that we're going to deliver healthcare to the world. If you think about it, the way that we've been delivering medical care up until the present day, it essentially condenses down to treating people who are sick. So in other words, people don't go to the doctor until they're sick, and then they usually get maybe admitted to hospital, and it's some sort of expensive form of healthcare is administered. Precision medicine ultimately is about stopping people from getting sick in the first place. So keeping people out of the doctor's office, keeping people out of hospital. Now the question is, how do we deliver this? And the revolution is that, again, if you think about the way that we deliver healthcare at the moment, it's based on the assumption that all people are pretty much the same. You know, if you go to the doctor with a certain disease, you get the same treatment as everybody else who's got that same disease. And that's just not good enough, because we know that everybody is different. People respond differently to different drugs and so on and so forth, yet we don't take account of that in the clinic. So what precision medicine is all about, it's about defining who people are as individuals, how they respond to different medications, what kinds of diseases each individual are susceptible of acquiring later in life, and what they can do as an individual to stop themselves from getting that illness. That's ultimately what this is about. Now, this is a perfect project for the Charles Perkins Centre to be embarking upon. The Charles Perkins Centre is it's a revolutionary experiment that's being performed by Sydney University, where it's focused on tackling one of the greatest healthcare problems for the future of the world, and that is metabolic disease. And by that I mean things like type 2 diabetes, cardiovascular disease, certain types of cancer, various neurological diseases. These are all diseases that have effectively arisen as a consequence of the change in environment, the modernisation of human life. And so that's what the centre is all about. It's to focus on that one problem, but from a very multidisciplinary point of view. And I don't just mean a couple of disciplines, I mean right across the board. We have people, of course, who are interested in the clinical aspects, in the biological aspects, but we also have engineers and mathematicians, people who are interested in sleep, health economics. All of those people are swimming around the Charles Perkins Centre like a galaxy. And I think this is unique, and it has the potential to really revolutionise the way that we deliver healthcare. Precision medicine ultimately will rely upon collecting lots and lots of information about individuals. And this won't just be biological information like one's genetic code. It'll also be things like what kind of exercise they do, how often they exercise, what do they eat, when do they eat, how do they sleep, what sort of social networks are people involved in, all of these things. And so by definition, we need to interact with individuals who have expertise in each of these areas. And I should say, this is not going to be trivial. Trying to get information, accurate information, about what people eat, for example, turns out to be very challenging because most people lie about that. So we're in fact trying to develop chemical tests whereby we can take a sample of blood and be able to tell from that sample of blood what people have eaten. So that gives you a sense of where this is going to go. Now ultimately what this will mean is that we can imagine that each individual will be swimming in a huge cloud of their own data that defines who they are as an individual. Now herein lies the challenge, and that is that we don't actually know yet how we're going to predict from that data what that person's long-term health outcome is, or what that person can do to actually offset their chances of getting a particular disease. So the real challenge is going to come in data analysis. So it's almost like the way that Google is approaching some of their major revolutionary projects at the moment. So for example, they've just announced that they've taken more than 10 million images off YouTube, fed that across this multi-platform, high-technology computing platform, and then are trying to train the computer to learn what different objects look like, and to do this in a completely unbiased way. So it's a form of artificial intelligence. So I think what we can imagine is using similar techniques for human data. So whereby we can imagine feeding computers, very sophisticated computers, these large data sets, and then the computer will actually learn from that data what that person is going to look like at some point in the future. So it's almost challenging to get your head around this, but I think that's what we can imagine if we have to look into the future. Many people believe that precision medicine is just about genomics. So that is, I'm sure we're all aware, there's been a genomics revolution over the last decade, and it's now in fact quite affordable for an individual to go and have their own genome sequenced. And of course this is going to make a huge impact on healthcare, but I think what we've now come to realise is that on its own it has limited value. So by that what I mean is that, again, coming back to this concept that, you know, as an individual we're all different. Part of that difference is our genome. My genome is, you know, many millions of base pairs different from yours or other people. But the other thing that segregates us all as individuals, for example, is we live in different environments. We all eat different kinds of food. We eat different amounts of food. We do different kinds of exercise. Furthermore, we might have been born under different conditions. Some of us were born by C-section, others by a vaginal delivery. Some of us were breastfed, others not, and so on and so forth. And it's actually the combination of all of these things together that conspires to determine who we are as individuals. And so if we're to understand this and actually use this information productively, we have to sample all of these things together. And that, I see, is going to be the success of this venture. I think one of the hidden secrets of precision medicine is that what one can envisage is the opportunities. So there'll certainly be, you know, great outcomes in terms of the way that we deliver healthcare in the future. But there's also going to be around this a whole series of other opportunities. So for example, I just mentioned that people will be swimming in a cloud of their own data. I can imagine there'll be data coaches. So people have their personal exercise coaches today. I can imagine people having their personal data coach tomorrow. So there's an opportunity. Also, there's the technologies that are going to arise as a function of this. I don't even believe we can imagine what the technologies for processing these data are going to look like 10 years from now. Today, we often wear Fitbits on our wrists. We carry our mobile phones, which we can measure how many steps we walk a day and all these sorts of things. I think the sorts of things I'm talking about are going to take this into a new stratosphere. And therein again lies the opportunity. It's people who are of a technological bent can get behind this and develop new industries. And I think this is going to change not just healthcare, but the way that economies actually roll out their future workforce, the way that universities, for example, teach their students, and so on and so on. So there's a lot of hope, and I think one can be optimistic that there are great things on the horizon if we get behind this precision medicine initiative.